In this lesson, we're going to be talking about the OSI model. What's the OSI model? Well, you can see here a diagram of the OSI model, which doesn't really describe what the OSI model is, but we'll be referring to this diagram as we go on, and I'll be flipping back and forth to this. So what is the OSI model? OSI stands for Open Systems Interconnection, and it's a 7-layer model that describes an architecture for communication. It's a standard communication architecture, and it's really modular, which you would expect from a layered approach. As I said, it's a 7-layer model. It was created in the 1970s as an architecture for distributed database systems. So you can see that there are 7 layers here, and this model really originated as part of work that was being done to create this standard communication architecture. In the 1970s, they were learning from the work at ARPA around ARPANET and the creation of the TCP/IP protocol suite and the birth that was happening in the 1970s around that, and IBM's System Network Architecture, or SNA. Observations from those two activities really went into the creation of this OSI model. Now, the OSI model is protocol agnostic. It's not tied to one specific protocol or set of protocols. As a result, it's pretty easy to lay different protocols and different protocol suites on top of the model, or at least fit them into the model. We'll be going through some of that as we go forward here. Let me show you the model again. We're starting from the bottom. The physical layer is really all about the physical definitions, not surprisingly. So we're talking about connection types, coax, 4-pair, fiber, etc. The physical layer handles error correction and detection on the physical medium. So we've got these things called collisions. When a message goes out on the wire and somebody else sends something at the same time, the two electrical signals are trying to cross the wire at the same moment, and we end up with this collision, and of course we end up with basically garbage, and the signal would be completely unintelligible. The physical layer is responsible for doing error correction and detection on the physical medium. Now, the data link layer is responsible for doing the translation from the digital data to physical signals. So it's got to do these frames in order to make sure that the messages are able to be sent across the physical medium. So it frames the messages out in a way that can be transmitted based on what the physical medium happens to be, whether it's fiber or whether it's coax or whether it's 4-pair wire. It also has physical addressing, so there's an address that's associated with the data link layer, and we'll talk about that in subsequent lessons. But what we're talking about there is the media access control address, or MAC address. Now, it also handles flow control and access control. And those collisions that I mentioned before, it's got to be able to recover from those, so it uses this mechanism sometimes called CSMA-CD, or Carrier Sense Multiple Access Collision Detection. Now, that's what Ethernet uses. So it senses that there's a collision and then does the retransmission based on a random hold-off timer. So if the hold-off timer wasn't random, you'd get people trying to send messages, getting a collision, backing off, and then both people trying to resend at the same time. And of course, you're going to end up with a collision again. So we have this random back-off timer or hold-off timer before people retransmit after a collision. Now, different protocols use different ways of handling this. For example, AppleTalk uses CSMA-CA, or Carrier Sense Multiple Access Collision Avoidance. So rather than detecting collisions, they have mechanisms in the protocol to actually avoid collisions. Now, the network layer, and we're up to layer 3 here. The network layer is actually responsible for getting messages back and forth across different networks. I've got multiple networks that I'm connecting to, and I need to make sure that I get my messages from my local network to another network that I may be connected to somehow. It handles getting data from one network to another, and by that I really mean it does routing. In addition to routing, it also does some repackaging of the data because we may have different physical connections on the other side and different layer 2 technologies. So the layer 3 has to kind of bridge that gap between those two different types of technologies. So layer 3 is there to get messages from one network to another network. As a result of that, we need another address for that. So we need a logical address to ensure that we can get messages from one network to another network reliably. So we have a logical address at the network layer. And in this case, if we go back to the model diagram, you'll see IP is actually at the network layer. So IP and the IP address actually sits at layer 3 at the network layer. At layer 4, we've got the transport layer. That's where TCP and UDP actually sit. And the transport layer handles end-to-end reliable data service. In the case of TCP/IP, it handles ports to differentiate traffic. UDP and TCP both have this concept of ports. So in addition to an IP address, you would communicate to a port, and that handles the differentiation between applications. So every application is going to have a port that it needs to communicate either with or on as it's sending messages. So that's how we handle different communication streams across the same wire. We have these layer 4 protocols that have different ports. So TCP and UDP, both examples of transport layer protocols. Now we have a session layer on top of that. That's layer 5. That controls specific dialogues between two systems. So layer 5, not surprisingly, does session management. This one's a little bit more abstract than lower layers, and sometimes there's disagreement over which protocols actually land here in session 5, because sometimes there's actually overlap between functionality. So typically, protocols like SSL and TLS, as well as SSH, would land in the session layer. There's also protocols like NetBIOS, for example, that typically gets dumped into the session layer because it manages the communication between two systems, and there actually is a session that gets set up as systems are exchanging files back and forth. Now we have the presentation layer. It manages how data is presented. So XML and JPEG, for example, would sit in the presentation layer. Finally, at layer 7, let me flip back to the OSI model, and here we have the 7 layers here. HTTP, FTP, SMTP, these are the application layer protocols. These are the things that sit the closest to the user. They do all management of connections. They handle error control if they need to. They handle session establishment, all of those sorts of things. Those get done at the application layer. And these are things like web access, email, file transfers. All of that stuff has some component that sits at the application layer. So one thing I want to point out here is it's layer to layer. And this may perhaps seem like it should go without saying, but it's important to mention this. One layer speaks to another layer. So each layer adds a header, which encapsulates the data that came before it, and each layer is responsible for peeling that header off when it gets the data on the other end. Let's go back to the model here, and we've got, for example, a web request. So that web request is going to originate in the application layer, and then it's going to go down to the presentation layer and session layer if there's anything that needs to be done there. For example, if there's a TLS connection, maybe you could say that goes through the session layer. Then eventually we're going to have to add ports to it. So I have to add a source port and a destination port, and the destination port's probably going to be port 80. Then I add the IP address at the network layer, and I add an Ethernet header probably on top of it, and I send it off. So it goes through the network, and then when it gets to the other end, we actually repeat the process in reverse. So it comes in on the physical layer, and the data link header gets pulled off by the data link layer on the receiving end. The network header gets pulled off by the network layer on the receiving end. The transport layer gets pulled off by the transport layer on the receiving end. It's not really an earth-shattering revelation to suggest that the different layers handle the same data whether they're on the sending end or the receiving end. The point, though, is that it's really encapsulated. The data gets all encapsulated, and it's really a series of headers that get extracted on the receiving end as the data makes its way back up the stack. In conclusion, there are 7 layers to the OSI model. That's the physical, data link, network, transport, session, presentation, and application. And of course, this is all layer-to-layer communication. You would never have layer 2 on one side communicating with layer 3 on another side. That's just not the way it works. So it's layer-to-layer communication.